Hello everyone and welcome to this video. Today we will talk about periodicity and physical properties of periodic table. There are many videos on the channel that talks about periodic table and periodic table trends. Today we will focus on the physical properties of periodic table. We all know that the periodic table first arranged by Mendeleev, where he arranged elements according to the atomic mass. In the atomic mass, yes, some elements can be arranged where you have the hydrogen 1, then you move to the helium 4. So you are increasing the atomic mass, but there were some gaps that Mendeleev himself couldn't explain, where you have the argon with atomic mass is equal to 40 and potassium comes after with the atomic mass equal to 39. Also, he couldn't explain the large gaps or the jump between the 1 and 4. So helium for hydrogen, it is the atomic mass is 1, then the next atomic mass is just starting from 4. So those gaps needed another way to be explained. After Mendeleev came the discovery of the subatomic particles, which led to the arrangement of elements into according to their atomic number. Now, if we looked at the atomic number, is the number of protons inside the nucleus or the number of the electrons outside surrounding the nucleus in neutral atom. Only in case of neutral atom. Now, if you looked at the atomic number, usually it is written down in the periodic table, and on the top you have the mass number, which is written on the top. Usually there are a few tables, periodic tables, which are arranged in the opposite way, where you have the atomic number on the top. So how we can know? Of course, the atomic mass is equal to the protons plus neutrons. This is why it has to be larger number than the atomic number, which is equal to only protons. Now, if we looked at the modern periodic table, you could see that elements are arranged according to the atomic number, where you will have 7 periods. Those are the horizontal lines, so those are periods. And you have 18 groups, those are the vertical columns, so those are the groups. Usually for periods we name them 1 up till 7, and we know that in one key shell will be filled with here 1 electron, then here is the second electron, then L shell will be filled in the second period, where you will have 8 electrons filling the K shell, moving to so on up till Q shell. Now, for the groups, there are 2 ways of numbering them. Either you number them 1 up till 18, where you will have the lanthanides and the actinides at the bottom of the periodic table will not be numbered. Now, if I looked at the other way of numbering groups, it is the Roman numerical and symbols. This Roman numerical and symbols will number S and B orbitals to be A groups. So I have here 1A, 2A, then because from group 13 up till 18, we will fill P orbital with 6 electrons. This is where we will name those groups 3A, 4A, 5A, 6A, 7A, and this group 8A, we will name it noble gases. For filling D, on that case, for filling D orbital, we will name our groups B instead of, so we will move from A to B. And in that case, my first 1B and 2B will be the group 11 and 12. As for group 3B will be the group, the third group in my periodic table. This is why the easiest is the IUPAC new way of numbering the groups, where you will have only 1, 2, 3 following numbers, not like in the Roman numerical symbols. You have 1A, 2A, then you jump here on that side to number the 3A, 4A, and the B will be D orbitals, where you will have the 1B, 2B, then on that side group 3 we will give it 3B. So the new way of IUPAC group numbers make it easier for us to know also the the valence electrons. For group 1 and 2, the valence electron will be equal to the group number, which means first group will have valence electron 1 and group 2 will have 2 valence electrons. From 13 up till 18, the second digit on the right will be the number of valence electron for each group. So in here, group 13, I will have 3 valence electrons. Group 14, I will have 4 valence electrons. Group 15 will have 5 valence electrons up till 18, where I will have 8 valence electrons. Now the trend across the period is usually you are increasing the atomic number, but you are decreasing the atomic radius. And you could see here the atomic radius is just decreases. This is because you are actually increasing the number of electrons and protons, while the distance remains the same between the nucleus and the shell. So, for example, in period number 3, you are filling the shell, the third shell, and in that case, the distance between the nucleus and the third shell remains the same, while you keep adding protons to the nucleus and the third electrons to the third shell. This would increase just the attraction between the protons and the electrons. So instead of here you have protons attracting 11 protons attracting to 11 electrons, you have 12 protons attracting 12 electrons, and moving, you are increasing with the same concept. This is why you could see there is a decrease in the atomic radius. Now, moving down the group, you are increasing the atomic number, but you are also increasing the levels, the number of levels. So instead of level 1, you are moving to level 2, level 3. So this, you are increasing actually the distance between the nucleus and those levels. This is why the attraction starts to decrease. So you have the atomic radius is increasing because you are increasing the number of levels, and this would increase the distance between the nucleus and the electrons of the outermost shell, which will increase the atomic radius. Now moving to the ionic radius. So you expect metals to lose electrons and non-metals usually gain electrons. So when it loses electrons, when metals lose electrons, in that case I have here example calcium. In calcium it loses 2 electrons, so you have the same number of protons inside, but you are decreasing the number of electrons. Take for example, if you remember the tag of war game, you have the number of electrons equal the number of protons, so the attraction this is the attraction in the neutral atom. Now if you removed one of the electrons, so you expect protons to attract more or have a significant effect on the attraction of electrons toward the nucleus. This is why you expect a decrease in the atomic radius from neutral atom to the cation. Now moving to the anion, it gains electron. So I have this example, which is a chlorine. It gains 1 electron. So you have 1 extra, like in tag of war, you have 1 extra player in this side. So in that case, the number of electrons would overnumber the number of protons. So what you expect is actually a decrease in the effect of the attraction of the protons towards the electrons. This is why you will expect the radius to increase. So I have here anion, where I have the radius increased from neutral atom. Now, if I looked at the trend in the period number 3, I have sodium, which lost 1 electron, will have, in that case, atomic radius larger than magnesium ion, which lost 2 electrons. Now, aluminium lost 3 electrons. This will make the atomic radius even smaller. And silicon lost 4 electrons, which has the least in this period. Now, moving to the phosphorus, you start to have this large increase in the atomic radius. And the reason behind that, now phosphorus gained 3 electrons. So phosphorus ion in that case is gaining 3 electrons, and those 3 electrons will increase the atomic radius or the anion radius in that case. And moving to sulfur, it gained only 2 electrons. This is why it have anion radius which is less than the phosphorus. So I have here phosphorus, I have here sulfur, and I have here chlorine. In here I have chlorine anion only gained 1 electron, and sulfur gained 2, and phosphorus gained 3. This is why phosphorus will have the largest anion radius, because it gained more number of electrons. Now moving to the, if I looked at the atomic radius versus the ionic radius, you could see in general you will have cation will have a neutral atom larger than the cation, where you will have in case of so this is the cation, and here you will have the neutral atom. The opposite is true when it comes to non-metals, because non-metals actually gain electrons. So you have here the neutral atom, and in here you have the anion. By that we came to the end of the first part in the physical properties. Next video we'll talk about melting points and electric conductivity. Until next video, thank you and goodbye.